So we'd like to welcome Gabriella Pizzuto, who's going to tell us about intelligent robotic systems.
So thank you to the organizers for inviting me. I didn't have to travel too far, actually. I just crossed the road from my office, so I'm quite fine. So I hope to convince you that it's an exciting topic to work on, robotic systems, and what we are currently working on at the University of Liverpool on creating the next generation of intelligent robotic systems. So I will start with a short introduction about myself. So I like taking pictures with robots. I like working with robots. So I did my MSc in Computation, Neuroscience, and Cognitive Robotics at the University of Birmingham. I did my bachelor in Malta. I'm originally from Malta, and I did it in engineering. So I started in computer science quite late, I would say. It was during my MSc. So I started working with robotic arms. I don't know if anyone is from Birmingham here, but there was we called it the robotics dungeon. So it was underground, and there was the lab there. I spent a lot of time during that summer. Then I moved to the University of Manchester, and I did my PhD in computer science here, working on the humanoid iCub robot. During my PhD, I was also part of a Marie Curie program, and I did some visiting projects as well at the Italian Institute of Technology to learn more about working with the iCub. I was basically fusing computer vision and language understanding on the robot. Then I decided I really liked working with robots, so I moved up to Scotland. So I moved to the Edinburgh Centre for Robotics. And I thought they have a really cool center for robotics, but COVID hit. So it was just mainly nice pictures, and I only used the robots for like 6 months before shutdown. Then I realized that chemists got back into the labs, and roboticists were still at home playing with simulations. So I decided to join a chemistry lab to deploy robot systems in their lab, so I could actually be in the lab again. So in 2021, I moved to the University of Liverpool to work on a European project. And we were basically trying to create robotic scientists. So the idea was that robots are faster at carrying out experiments. There was a lot of crisis with the vaccine and trying to come up with a new vaccine. We also need to accelerate how we discover new materials. So I thought it was a really exciting time to join this project. And in 2023, I started as a lecturer here in Liverpool between computer science and chemistry. And I also joined the Royal Academy of Engineering, which is a research fellowship, and it's a 5-year research program that will allow me to pursue my research. So that's basically in a nutshell. If you need any tips on an academic journey, which is very different even for the CV, we like long CVs, so they were absolutely right. But I will give more information at the end. So what does robotics look like in real-world applications? So I know there was Ocado downstairs. They also have some interesting robotic systems as well. I think what I'm truly excited about is using robotic systems to be able to carry out tasks that, in my opinion, or in general, could be hazardous for humans or could help humans in some way or another. So if we look at the videos, we have the first one, which was a project in Edinburgh. We have a quadruped robot, and it is navigating on an offshore oil rig. Then we have some robots at Amazon. So there is the warehouse, and they have some robotic arms and some mobile robot bases. I'm sure most of you are familiar with the new Tesla humanoid robot, so it was just released last year. It's quite dexterous, so it's able to do some grasping tasks, and the research has been quite accelerated. So I would envision some humanoids in the future to also be part of our lives. And then the other videos are more robotic systems for lab automation. So the top right is at the University of Liverpool, so that's our robotic chemist. Then we have some Yumi robots, which are 2-armed robots in hospital labs. And another robotic chemist in China is carrying out some materials experiments. So why am I so excited about working on robotic systems in laboratory automation? So if we look at the 1900s, I'm sure most of you know the scientists. And if we look in the 2020s, chemistry labs look more or less the same. So this is The right part is a quite advanced lab. It's the Materials Innovation Factory. There isn't a lot of robotic systems still, so for us it's an exciting time to start thinking about what challenges we need to deploy robots. So why is it so challenging to deploy robots in these environments? So when I joined the University of Liverpool, I spent some time looking at how chemists carry out their tasks. If you look at these videos, you can see that they're very highly dexterous tasks. So chemists effortlessly carry out their experiments. They use filter paper, which is a hard robotics challenge. The tools they're used, they're not very robotic friendly. And what they do very easily is that they look at the samples and they know what is going on in the reaction. And in lab automation, we're still a bit behind in terms of trying to move closer to how we do it with human chemists. Of course, it's not all not automated. So there is some equipment like this. We call it the ChemSpeed. So this is basically, I call it like a washing machine. So it's very good at doing one specific task. So it dispenses some solids, it dispenses some solvents, and it mixes things together. There's some fixed robotic arms. So this one, I think, is in Taiwan, if I'm not mistaken, and we have a fixed robotic arm that is carrying out a specific reaction. As you can see, it's very robotic friendly, so you have the analysis equipment behind. The robot is quite industrial, and everything is kind of fixed in the same place, so everything is kind of rigid. Then, I think what is particularly exciting about Liverpool is that we have the mobile robotic chemists. So our vision is that we need robots and humans to work in the same lab. So the robot is working in a lab that humans can use. It's using the same analytical equipment, the same glassware, and everything is more or less similar to what human chemists would use. And this is different transitions of automation to robotics in chemistry labs. So there are a lot of advantages, I believe, to using robotic chemists in our labs. So, of course, robots can work around the clock. They promise higher efficiency. This is quite useful also in materials discovery because there are some reactions that you need to do around the clock as well. And so a lot of experiments are longer, continuous, they're very boring. There's human mistakes as well that are done because they're done manually. So automating them is important. There's a lack of reproducibility as well in science, so there's a lot of published work that cannot be reproduced, so having robots carry out these experiments can lead to shorten this gap. And finally, like a lot of chemicals, especially the ones that are in the early stages of discovery, they're quite toxic and harmful. So I think if we minimize exposure of humans to these chemicals, it will be safer for human lives. So that is a bit of a motivation on why and what we're doing with robotic chemists. And today in my talk, I will focus on two simple research directions that I have been carrying out and with the rest of the team here in Liverpool. So the first one is we want the robots to be able to carry out the same human skills that humans carry out. So why is this so important? So if we look at the different material samples that we have in the labs, these are two crystals, we call them, and it is the same experimental procedure. It looks very different. One is needle-like crystals, the other one is more powdery, but it is the results from the same reaction. So as you can imagine, this is very hard to automate because the product is not the same. So the robot needs to be able to understand that they are different and adapt to the changes in these materials. So in the previous work where you saw the mobile robotic chemists, the work was mainly focused on this part. So it was the mobile robotic chemist. This was the robotic part that was carrying out the reactions. Then you have what we call a chemical brain, which is a Bayesian optimizer, and is optimizing the reaction that is being carried out. And in my research project and also my research direction is to focus on acquiring skills and looking at different methods on how we can improve the robot's capabilities to learn these skills. So I like to see it as more we're trying to develop another part of the robotic chemist brain. So in robotic manipulation, for those of you who are familiar with that, we have been studying and trying to transfer human motor control for years now. So in humans, we see it as a control system, basically, for those of you who are familiar with control. So you have some feed-forward dynamics, which is the model that you build inside your brain, in very simple terms. And then you have some feedback, which you adapt when something is new or there is a disturbance in the environment. And in robotics manipulation, we kind of take inspiration from this method, and we build a control system that is composed of a feedback controller and a feed-forward controller that is inspired by the human motor control, and this is done to control the torques of the robot. So in some of the earlier works, we looked at this control system. So the idea is to be able to do the same tasks that humans are doing. So we looked at this part, this control system. So you have a feedback controller, which is the KP and KD. And the feed-forward one, you can learn it through either analytically or you can learn it through a regressor model. And in some of the methods we looked at, we learn it through efficient Gaussian process methods. So that's one way of learning motor skills. Another one that we were looking at and more applicable to the lab is scraping samples. So you have these crystals, and these you would transfer them for diffraction, X-ray diffraction. So you need to analyze what these molecules actually are. And to do this, scientists spend a lot of time scraping samples. So they carry out this motion for all of their samples before they move on to the X-ray diffraction. So another way we have been learning skills is using deep reinforcement learning. So I'm sure most of you are familiar with that, but the idea is that the robot carries out an action, and based on the action that it takes, it gets a reward or a penalty on the task. In terms of the robotic system, the action can just be a change in the position, which here is a Cartesian pose, and the observation in this case can be the proprioception of the robot, which is the XYZ, or the force feedback that the robot has at the end effector of the gripper. And basically the goal is a distance goal, so you're trying to minimize the distance between where the robot is at and the goal that it's trying to achieve. So in terms of the laboratory sample scraping task, we formulated this in this manner. So we have the robot scraping the vial of the wall. So it starts from the top of the vial and it goes down in a vertical motion. And the goal is to maintain contact with the wall and to, in the simulation, not to topple over the vial and to minimize the distance between the end effector and the end of the vial. So we carried out this in simulation environment, very simple environment, and we also did it with the real robot. So as you can see here, the robot was able to scrape the sample. Okay. So far I've showed you you can take inspiration from human motor control using control systems. You can also adopt a reinforcement learning approach. And in another work, we looked at using rule-based, so fuzzy logic to be able to handle different samples. So in this video, the robot runs using a rule-based method. So here the robot is weighing different samples. Again, it is using the same glassware, the same equipment that human chemists would use. So it is very much inspired with how humans do it. And depending on how much it needs to weigh and the tracked goal, the tracked target of the scale, it chooses the different spatulas. Okay. So that was the first part of my talk on how we can have the robots manipulators do similar skills to humans in laboratory environments. In the next part, I will talk a bit about how we used computer vision and perception methods to understand samples non-invasively. So this was particularly important because a lot of times when chemists carry out reactions, they are able to look at their samples and know whether the reaction has worked or not. So we wanted to understand if we're able to take a similar approach using perception methods. So the reality was that when I joined the group, I expected it to be a very easy computer vision problem. So you would look at the samples, they have nice reactions, which is very easy to solve. And then in reality, this is how the labs and the samples in the labs look like. So most solvents, organic solvents, are transparent. The laboratory equipment is also transparent. You have white equipment, white samples, so it's much more challenging. So while the robotic chemist in the video carried out experiments throughout 7 days, it was not able to visually inspect the samples, so it was just going through the motions and not fully understanding what it was going through. So what we did was try to build a simple classifier. So we had this robotic process, which is the first part. So it's like baking a cake, basically. You dispense some solid, some liquid, stir it, and then you look at the sample, and then you decide whether it has dissolved into the sample or not. For those of you who are familiar with convolution neural networks, we use a multi-stage neural network. We use an image segmentation, which was at the time Mascar CNN. It was the state of the art, but now there are better methods as well. And then a simple classifier to tell us whether the liquid has dissolved, the solid has dissolved or not in the sample. And the nice thing about this, it allowed us to work in real laboratory settings. So all of our research is focused about carrying out these processes in real laboratory conditions without any human input, and of course, to carry it out in different laboratory environments. So another project that we were looking at to understand whether we're able to assess samples visually or not was trying to understand the viscosity. So the idea is that different liquids flow differently, and if we have a robotic system that's able to analyze this, this could be useful, for example, in collaboration with industry like Unilever. They were interested in the flow of shampoo, for example, and this was using a basic 3D convolution neural network to track the motion of the fluid and then classify whether it's highly viscous or not viscous. Okay, so this is the video. And it's also able to sort out the samples depending on the viscosity level of the liquids. You can see the motions, that's the video that is fed into the neural network, and then the robot makes a decision based on the prediction of the model. As you can see, the gels are quite transparent, so it's quite challenging to track the liquids even visually. So we also looked at how this method compares to humans. So what was interesting was that if we look at different solvents that all look the same, as humans we're able to understand how they flow. But most of these solvents in labs, they flow, if they have similar viscosity classes, then it's really hard to detect them with the human eye. So we studied how humans would perform in comparison to the robot, and I think the robotic system was around 88%, and human chemist was around 35%. So the model was able to pick up patterns that even humans couldn't do it visually. So in terms of our current ongoing projects, so we have 2 research directions that we are currently working on, and since everyone is using since everyone is using ChatGPT and these kind of models, I wanted to portray the projects of my current students in terms of these networks. So we're looking at how robots are handling different materials, and we're doing it from a chemistry lab setting, but of course this can be applicable to different industries. And again, as we are very excited about having the robotic systems in human labs, we also want to understand how humans and robots can work together and how the robots can become safer in terms of working in close collaboration with humans. So just to wrap up, I think previously there were a lot of slides, a lot of presentations on how an industry job looked like. This is how an academic job in robotics look like to some extent. So I get to spend a lot of time playing with robots. Since my master's, I say, in undergrad, you also get to meet a lot of exciting people, travel a lot, I think, and visit different labs, get to see other robotic systems. So I think overall it's very exciting. And if you have any questions on how does that look like in an academic setting, I would be very happy to answer that. We also have a new center for doctoral training. So it's in digital and automated materials chemistry. But there are some robotics projects as well. It's just started this year. So for those of you who are finishing their masters or towards the end of their degrees, I would encourage you to have a look at the pages. It's a 10-year program, so even if you're first year or second year, there could be other opportunities in the coming years. So in conclusion, I think, at least the way I see it, building robotic scientists is a very broad robotics project. I think it's important to bring together different disciplines. One thing that is particularly interesting and important is safety and how we make these systems more robust, because we're working in a safety-critical environment. I think generalization to new experimental workflows, especially when working with chemists who are non-expert users of robots, is really important. And I think it's particularly exciting because you get to see your robotic systems being used by chemists, so you get to see the work that you have developed being used in real laboratory settings. Some acknowledgements to collaborators and the research funding that has funded my research, and I'm happy to take any questions.
Thank you, Gabriella. And the slide that she put up about the Doctoral Training Centre, in case anyone needs that translating a little, because that's what they call it now, if you're looking for a PhD that's funded, you want to be looking for a doctoral training centre or centre for doctoral training. So I know that some of you have already asked about getting funded PhDs, so you might want to talk to Gabriella later. Anyway, questions?
And if you have any questions about the PhD program in Liverpool, my students are here, so feel free to ask them as well.
Hello. Slightly dim question, I guess. When you're working with robots like that robot with the two arms, how fast does it move? It's like, does that sped up, the video?
I don't think the two arm is sped up, but you can change the velocity levels.
Okay. And do you find yourself like anthropomorphizing them? Do you find yourself thinking, oh look, it's angry, or look, it's happy with that one?
It's happy.
Because I look at that and I think, it's just two arms, but somehow, some of them it looks happy. Like, it's just happy there, right? And this one, right, when it gets one that's... I was really happy with that one.
Because it's a good sample. So
yeah. But do you not find yourself thinking that?
So, yeah, I mean, there's a lot of research. There's a lot of research on emotions with robots, and I think because it looks human-like, it's easier to attribute.
It's just like two arms on a brick, though. How do we turn that into a human? Sorry, I'll stop now. Has anyone got a better question than me?
Hello, Sarah from London South Bank. Do you get to build any robots at all from scratch?
I think as an undergrad I built some robots. right now, because we need them in our research to be repeatable, we buy commercial industrial ones just because they're more repeatable. Usually the robots that we buy, you just put them out of the kit and put them together. My students want to build robots, so I think maybe in the future we can start thinking about building them. Right now, I think we're still not there.
Cool, thank you.
Hey, I'm Danny from Hertfordshire. Which one is your favourite robot of all time in the lab, and do you name them? Like, do you go into the lab and be like, "Hi, Steve, how's it going?" Like,
yeah. So I think my favorite robot. I mean, if you want the movie style, I was a Baymax fan, and then there was in terms of, I used to like humanoids a lot, especially during my PhD and postdoc, and there was the Asimo one by Honda, which was one of the early humanoids. So I'm a bit older, so I think those were the ones I used to appreciate. Now I have a favorite manipulator, so it's the Frank-Chemica Panda, so that's the one I enjoy working with the most, but Baymax would be my favorite, I think. And the other question was... And the lab is the Panda, and in terms of the names, so yeah, as roboticists, we like to name robots. They name them also in the lab, so it's, and they're very weird. Like, for example, in my PhD, we had some pepper robots, so they were like all the spices, so we had salt, pepper, cumin, cinnamon, so yeah, computer scientists.
Hello, I'm Barney from University of Wolverhampton, and my question was, like, do you have any robots at home that do your housework and stuff like that? Like a whole selection for different tasks? Since they can work in the kitchen as well if they work in the lab.
Yeah, so I think in the kitchen, so my partner is Italian. To him, you need to put the love and passion in the food. So I don't think that would be possible. My parents at home have the Roomba robot. So we have that one that's very common. I would love to have a robot at home, so maybe I can take one at some point and play with it. They're a bit too expensive right now to put them in the home, so the arms, they are around 25K.
Oh, okay.
So we're not there yet, unless you have like a small toy kit. We were looking actually at some quadrupeds. I think they're around 3K, so maybe I can have one at home.
Yeah.
Yeah.
You can make like an experiment that's based in your house and then take it home for research purposes.
Yeah, work-life balance, not that great though.
Okay, one more question. I think we had one over that side.
So, in most of the examples you've shown, it kind of looks like the robot works independently, right? How possible is it that, or how soon would it be that you would expect you could have humans and robots working, but autonomously, not like the Da Vinci where a human's controlling it, but the robot can work on its own and still be aware of the human working and not get in the way?
Yeah, so I think there are two questions to that. So if you want the robots and humans to share a workspace, I think there's a lot of things you need to consider. It's not just the technology, legislation if something goes wrong. So I think in that aspect, you still need to think about that. In lab automation and material discovery, the robots are the goal of the robotic system is to carry out an experiment for a long time. Otherwise, for the chemists, it's not good enough. So you want it to run for weeks, ideally months. In that case, they would prefer to sacrifice removing the human or putting them in another part of the lab so the robot runs repeatedly and you don't worry about safety if something goes wrong. So it depends mainly on the application. I think in household robotics, for example, you need to share the workspace, the home with a human. So I think in that aspect, it will take longer to be able to have humanoid, I think, but maybe I think Elon Musk can prove us wrong. But we can maybe, it will take longer. In lab automation, I think it might be faster. And I've seen, I think, a lab in Germany that they had a robot even going up between floors, between floors and labs between different, same building, but different floors. So it was carrying out quite a long experiment. But it looks like they're carrying out experiments autonomously, but for humans, and especially chemists and humans that are not robotic experts, they will lose interest in the robot quite fast if it breaks. So you want to make sure it's quite repeatable before you would actually deploy it in human environments.
Okay, thank you very much.